Hi guys, today we're going to do a new topic, continuous probability distributions. Before we start, please have a look at all the terminology that you need to know for this topic. I put some couple of few in there. Now, probability density function, continuous random variable, which means random outcome. As you can see, it's something to do with a continuous random variable with integral gives the probability. Now, sort of something to do with discrete data and continuous data. So I'll put that in there. It's not that important, but I think it's something that it's coming from their area. So we learned about data. There was a numerical and categorical data, and with the numerical data we had a discrete and continuous data. The discrete data is the one that is fixed data that you can count something. Continuous is something that it's not going to finish nicely, like it's not fixed. It's continuing, it's growing, okay, as the time passes. Sort of like a height, weight, and temperature, that sort of thing. Let's have a look at the question. Question 1, like example 1 from the Maths in Focus. This table gives the results of a survey of different times that runners take to complete a race. Now, part A, we just have to add a column of relative frequencies. Now, relative frequency is like probability. So we are really looking at a probability here. So we need to find the total outcomes here, which is total of the frequency. So if I actually add all this up, I will get 32 here. So my total frequency is 32. Now I can do relative frequency, which is the probability. So for the score 0 to not quite 4 here, it's just before 4. So it could be like 3.99999, something like that, but not 4. Okay, so we do have 0 to closer to 4, but not quite 4. So let's have a look at that. So I'm going to put 6 over 32 because that's my total outcome, and that's simplified as a 3 over 16. And then I'll put 8 over 32. I'm just going to put it all out of 32 first and then see if I could simplify this. Okay, now second one we can simplify as 1 over 4 quarter. This one 1/8, and then this one is 1/16, and that's what it is. Okay, so that's what a relative frequency is. Relative frequency is the representing probability. Now, probability, you can actually represent it as a decimals or fractions or percentages. In this case, we're going to stick with fractions. Now, sketch a frequency histogram. So I just got it here on the right-hand side. Now, remember, there's a gap. There's a little gap there at the beginning. Now, there's a couple of things we need to think about. First thing is score, okay? We're not going to put the range as a per score, so we need a class center. The first one is going from 0 to closer to 4. So it'll be 0, 1, 2, 3, and then 4 is something not quite there, but it's close to there. So I'm just going to put it like that. So what is a class center? What is a middle? Okay, center. So we need to have a middle. Okay, middle one is 2. That's my class center. So that's 2 here. The second one was including 4, 5, 6, 7, 8 is not quite there. Okay, so that would be 6. So as you can see here, score, we got 2, 6, 10, 14, 18, 22. Okay, because that's the middle part. Now, second part is the scale for your relative frequency. If you look at the table from part A, what are the denominators we have? There were a few denominators, right? So there was a 4 there, there's a 8 there, there's 16 there, that's a 32. Now, I'm not going to do maybe 4 and 32 is a bit too big or something, but maybe I'll pick between 8 or 16. But because the textbook solution did 8, so I'm going to use as 1/8 as my scale. And then here it is a histogram. Okay, so that's what we did. Okay, so part C, estimate each probability. Now, this is, let's have a look. It's not something we can just find one value and then that will be my probability. It says here the x is less than 12. So if you look at the table, so if I look at that, I can just add all up to here. Okay, so that's a 3. Okay, values I have to add. And then part 2, I think it says bigger than equal to 16. Bigger than equal to 16 is up here, these two, right? And then the third one, it says probabilities between 4 and 8, but 4 is inclusive and 8 is not. 4 and 8 is not inclusive, it's this one, isn't it? So the probability is relative frequency. So we just have to use these values to answer our questions. So here, let's have a look. This one, we had 3 values add up to, wasn't it? 32, and I will get 25 over 32, and I can't simplify, so I'm going to leave it as it is. And then x is bigger than or equal to 16. There was 2 values that satisfied this condition. That was 2 over 32. Now when I do that, 3 over 32, okay? And can't really go any more than that. Okay, so I'm going to leave it as it is. Now, only thing that was satisfying this condition was only, what was it, a quarter. Okay, so that was what it was. So it says the times in the above example are values of a continuous random variable outcome. Okay, but sorted into groups. That's what we did, 0 to just before 4 and the 4 to just before 8, something like that. So while we can estimate probabilities using relative frequency, we use other methods when dealing with continuous data. Okay, now these are sort of full on here, but it's not too bad. So let's have a look. Continuous probability distributions. Okay, with continuous data, we can't really draw a histogram as we did it in example 1 because you will have so many columns because it's a continuous. You will have so many columns in a histogram. So the width. So imagine this column is going to be sliced into thin, very thin, like a discs, okay? Sliced it because it's continuing, like, very, very small, thin. So that's what it means by 0 width. Okay, so and it becomes curved because you can't really see it because it's so small. Okay, and when they talk about a continuous probability distribution, it's talking about the whole graph, the whole thing. Whole thing is the continuous probability distribution. But when we talk about probability density function, is this y equals p of x. Okay, that's what it is. And important thing you need to think about, the probability density function, otherwise we call it PDF, has area 1. Okay, so for a continuous probability distribution, the area under the curve must be 1. So under the curve here, the areas on the curve here has to be 1 because it's a probability. You can't go more than 1. Let's have a look at this part now. Okay, this part. All right, what does it say here? With a continuous probability distribution, we cannot calculate the probability for a single outcome, like a discrete. Okay, discrete. Instead, we can only calculate the probability for a range of values. Range of values. What does that mean? It means something that we're going to use integration, because we're talking about area here. And then we're talking about limits, range of values. Now, also what that means is this. We can't have the probability of single discrete value of x as a vertical line would contain no area. So for example, if we just send a 1x value, you're just going to have one just line, single line. There's no area to find, isn't it? But if we had the range of values, which is normally 2 values between, so we got 90 and 100, and we can actually find the area. That's why we can't have a single outcome, but we have to have range of values. That's what it means. And also that area under a probability density function, P of x, it's nicely sort of bell curve, okay? Bell shape. And also what does that mean is it's like a start and the finish of the bell curve never ends. So here it goes forever to the negative infinity, and that's positive infinity. Okay, it looks like it's finished, but it's not. It's keep going, closer to the x-axis, but keep going. Okay, and total has to be 1. The area under the curve is 1. Okay, so that's the very, very important part that you have to remember. All right, example 2. A function is given by f of x equals 3x squared over 26. That's parabola, okay, for between 1 and 3, like inclusively. And then f of x equals 0 for all other x, the rest, okay, is 0. So we're only going to look at when the x value is 1 and 3 there, okay? So we're not going to look at any other ones because they're all going to be 0 anyway, so it doesn't really matter. So if I can sort of sketch it in a simpler way, it'll be this. Okay, so for a continuous probability distribution, the area under the curve must be 1, but that was the condition, wasn't it? Right? So in other words, it's a PDF has area of 1. Okay, so drawing the graph, notice that the area will be 0 for all x values outside of 1 and 3. That's why we don't have to worry about the rest, but 1 and 3. Okay, so let's have a look. The question we have to do is to show that it is a continuous probability distribution. Now, what does that really mean? It means we need to prove that the area under the curve is 1. If it is, then it's the continuous probability distribution. All right, so let's have a look. Area equals from 1 to 3, and then I'll go 3x squared 26 dx. Then I will just integrate normally x cubed over 3 over 1. Okay, and then I'm just going to take 1 over 3 out because that's another constant, and I don't want to deal with a constant inside with the x. So that will cancel out. So I'll left the 1 over 26. And here, 3 cubed is 27 minus 1. is 26. Ah, beautiful. So the answer is obviously 1. And therefore, we can say that f of x is a continuous probability distribution. Now, part B, a function is given by f of x equals ax squared, another parabola defined for the domain 0 to 5 inclusive. And find the value of a. Interesting. Find the value of a. So we don't have to prove anything. And for which this is a probability density function. Okay, this is a PDF. And PDF has a area of 1. Okay, so we got, it was given. This was given information. Okay, we don't have to prove it. It was given to us. Okay, so now we just have to find the value of a. So a equals 0 to 5. And then what we had was ax squared dx equals 1. So it was given. Now I'm going to take a out. 0 to 5 x squared dx equals 1. Now I'm going to do normal integration there. Oops. 3, 5, 0 equals 1. Okay. So 5 cubed over 3 minus 0 over 3, so it's a 0. And what I have here is 125 over 3 equals 1. And a equals, it flips over, 3 over 125. So that's my a value. And that was not too bad, wasn't it? So one thing you have to remember is a PDF has area of 1. Okay, that's all for this lesson. All right, see ya. Bye.